Okay, so welcome back. And just so you know, you don't need to this is just crunched. We're not still using aircrack in combination with it. Uh, the crunch can be used to generate password lists for all sorts of things, for web logins, for app logins, for whatever. And you might think, oh, well, Ermin, like, that's not something that's in the realm of possibility, but it's not. It really is in the realm of possibility, because when I was in college, we used to sit, and the professor, every time they would log in to the professor network and to the professor login place where they have all their lectures and all the other things. And you could see, and when they would log in, they would actually hook their laptop up to the projector and then they would log in. And while they typed their password, you could actually see the length. So over a longer period of time, every time they come to log in, you come and ask a question, and if you pick up a character or two, you don't need to know the whole password. You can just see a character or two and a probable character set, and which will enable you to actually generate the password rather easily. That was one of the weaknesses which I exposed there, and we had a counseling session in that regard to actually turn the projector off and then type in the password. And you don't even need to see it because you can hear it. So you can hear the amount of clicks that is made physically, so you can know the length, and that reduces the amount of probable combinations significantly. But that is beyond the scope of what we are going to do today. So I'm just going to go ahead and insert another number here to make this a little bit shorter so we don't have to wait an eternity for this to finish. I mean, it's not going to be an eternity now. It's as long as it's in terms of gigabytes or terabyte or even terabytes, you are facing a reasonable amount of time to actually finish. Great, I have my command here. Let me just see if I can scroll back. Okay, so I've just typed in this command, and I'll explain it in a moment. Let me just modify it a little bit so that it's what I hoped it to be. So dash, and you can also specify this dash comma. Comma represent actually dash percentage sign. It states that there are no repeating numbers. So one here and one here. So dash D, 1A, so it means that only one consecutive letter of the same type can be typed in, lowercase that is, and only one number at a time can be there. So you can't have 1, 1. You can only have 1, 2, 1, 3, or something like that. This will also reduce the file size and the amount of time actually required to crack this. So these are perfectly crackable things. I'm just inserting letters here that I know that are there because I don't want to wait for too long, because obviously I'm doing a tutorial and I'm just showing you how to do it. So you, at the end of the command, you will need a pipe symbol. You will need to type in pipe. So you type in whatever you need to type in for crunch, and then you type a pipe, and then you type in aircrack-ng -w. -w is used to specify the dictionary file, but we're not going to be using a dictionary file. We'll just type in a dash so that it takes the output of crunch and uses that as a dictionary, basically. So they're not being stored anywhere, they're just being generated. And then B, which is the BSSID of our wireless access point from before. You can get that quite easily by just typing airmon dash no, sorry, arrow dump dash ng, and I don't know the name of the interface. Fig. So arrow dump dash ng vlp12s0u2 mon. Right. You need to be root. So let just go ahead and do this. And you can just get it from here. Just follow up the BSSID and find your wireless access point, and that's going to be it. I've changed my wireless access point. I've actually taken up another router, which I'm going to use for some testing here. And this is its new BSSID. So I just performed another capture file, but doesn't really matter. It makes no difference whether you are using one capture file or another one, as long as you have created one. And then I'm going to use 2crack-01.cap. Keep in mind that your file name could be different. It could be something else. But it doesn't matter. I've shown you in the previous tutorial how to name it, so yeah. And you will be using the .cap file, so that is the one that you need to take, not the other ones. And then let's go ahead and press enter. And there we go. It started doing it, but let me just go ahead and break it and stop it and then start it up again so you can actually see what's going on the screen. And there you go. So this is much more convenient. So you can see that the amount of keys that are being tested is rising, and I'm still doing certain things in the background like encoding and recording this video. So the CPU time is still being consumed. But it's going to get around 10,000 combinations per second. Key/s stands for keys per a second. So there are a good amount of combinations that are going to happen here. And as you can see, it's going to try out every one of them. It's altering the ones we've stated to alter. It's not altering the others. But just for the sake of the test, I'm going to go ahead and shorten this so that you can see how a successful output looks like. I mean, you can just leave it like this. It's going to find it. But okay, let's see if this is going to be any better. There we go. It says key found, and it did find it. As I said, I've just shortened it for the sake of the tutorial so that you can see, so that you don't need to wait hours or days for it to actually show some results. But let me just show you something else as well. Let me just show you the load on the CPU cores and the temperature